Size matters. These mini black holes would be incredibly small, possibly on the order of subatomic particles. Their size is constrained by the need to balance gravitational collapse with quantum effects. Cosmic ray creation. Some theories suggest that mini black holes could be created by high-energy cosmic rays colliding in Earth's atmosphere. However, these would evaporate rapidly due to Hawking radiation. Unseen and undetected, detecting mini black holes is challenging because they would not emit significant amounts of light or other forms of electromagnetic radiation, making them elusive and difficult to observe directly. Gravitational lensing. Similar to larger black holes, mini black holes could cause gravitational lensing, bending the path of light as it passes near them. Detecting this effect could provide indirect evidence of their existing. Primordial black holes. Mini black holes could have formed in the early universe due to high-density regions collapsing under their own gravity. These primordial black holes would have formed before the first stars. Evaporation timescale. The Hawking radiation emitted by mini black holes would cause them to shrink and eventually vanish. The smaller the black hole, the faster this evaporation process occurs. Extremely small ones might evaporate almost instantly. Mass range. Mini black holes are theorized to have a wide range of masses, from as small as a grain of sand to the size of a mountain. The mass determines their properties, including the rate of Hawking radiation. Micro black holes and extra dimensions. Some theories in particle physics propose the existence of extra spatial dimensions. In such models, mini black holes could be created at high-energy particle collisions, providing indirect evidence for these extra dimensions. Quantum gravity. Studying mini black holes is crucial for understanding the intersection of quantum mechanics and general relativity, an area known as quantum gravity. Currently, these two fundamental theories of physics have not been successfully unified. Cosmic microwave background. The Hawking radiation from primordial black holes could leave imprints on the cosmic microwave background radiation, providing a potential observational avenue for detecting their existence. Information paradox. The concept of Hawking radiation has led to debates about the fate of information that falls into a black hole. Resolving the information paradox is a significant challenge in theoretical physics. Cosmic significance. Mini black holes could have implications for dark matter. If they make up a portion of dark matter, their properties and potential detection methods become crucial for understanding the mysterious substance. String theory connection. Some ideas in string theory propose the existence of tiny, one-dimensional strings as fundamental building blocks of the universe. Mini black holes could play a role in the exploration of string theory. Experimental searches. Physicists are actively searching for mini black holes in high-energy experiments, such as those conducted at particle accelerators like the Large Hadron Collider, LHC.